Hello and welcome to lesson 4D, Systems of Equations with Word Problems. All right, guys, so the key to this section is being sure up front to define what your variables are and to look for your 2 or 3 equations depending on the number of variables in your problem. So let's take a look at this first one. Example 1 says that tickets for a play cost $5.50 for adults and $3.50 for students. If a total of 120 tickets were sold and the total amount of money collected was $600, find the number of each type of ticket sold. Well, we've got 2 variables. We've got a number of adult tickets and student tickets. So I'm going to write that first. And we really have 2 sets of information here. We have the total number of tickets is 120. That means x plus y must equal 120. And we have that they collected a total of $600. Well, if my adult tickets are $5.50, then that means 5.50x plus $3.50 for students, $3.50 times the number of tickets for students, y, must equal 600. Well, those are my 2 equations for my system. And I'm now going to solve. I'm going to use substitution. So I'm going to take this problem right here and say that x is equal to 120 minus y. And then all I have to do is plug in. So I'm going to say 5.5 times 120 minus y plus 350 times y is equal to 600. We distribute to get 660 minus 5.5y plus 3.5y is equal to 600. I'm going to move some things around so I get negative 2y is equal to negative 60. So I end up getting that y is 30. That means we sold 30 student tickets. Well, I now need to figure out how many adult tickets. There we go. Well, I plug that into x plus y equals 120. I also know that x equals 120 minus y, so I do 120 minus 30 to get that we sold a total of 90 adult tickets. So 90 adult tickets. Guys, you must always, at the end of these problems, interpret your results so that we know what each of those numbers stand for. If you just gave me x equals 90, y equals 30, I'd count that wrong. Even worse, 90, 30, I'm going to count it wrong. Got to tell me what it means. All right, guys, let's look at the next. I want you guys now to try this problem. So go ahead and take a moment and answer it. Now let's take a look at example 2. Example 2 is going to have to bring in some of our old knowledge from geometry. Let's take a look at this picture. Ooh, my picture didn't show up. All right, guys, give me a second. I'm going to redraw this picture. All right, let's take a look at this. We have some things to remember from geometry, and they are as follows. We know that linear pairs, or those are 2 angles that make a line together, they're going to add to 180. Well, when I look at this, I have a linear pair right here. That x plus 40 plus y, those must add to 180 degrees. The other key piece of information is that when I have boundary lines that are parallel, and they tell me the parallel lines in the figure below, when I have boundary lines that are parallel, then consecutive interior angles, that would be these 2 angles, they're also going to add to 180 degrees. So x minus 60 plus x plus 40 must also equal 180 degrees. Now this is a nice system because I really don't have to do substitution or elimination because the second equation can just be solved. I get 2x minus 20 equals 180, or 2x equals 200. So x is itself 100. And then I'm now going to plug this back in up here. And so I do 100 plus 40 plus y equals 180. So y must be 40 degrees. And so those are my 2 answers. All right, now we've got a triangle, which again, we can't see. I'm going to redraw it. All right, guys, we have a couple pieces of information remember on this problem too, and they are linear pairs must sum to 180 degrees. That means that this set right here, that's b plus 30 plus c must equal 180, and my other linear pair is over here. 2b minus 10 plus a must equal 180 degrees. And my second piece of information, the angles in a triangle must sum to 180. That means A plus B plus C must add to 180. Well, that gives me 3 equations for 3 variables, so let's take a look. I'm going to rewrite these 2 equations here so that they can match up with this third one better. So this guy really becomes B plus C equals 150, and this one really becomes A plus 2B is equal to 190, coupled with our A plus B plus C is equal to 180. I didn't have to change him. Now, if you look, my first equation, this guy right here, and my last equation, if I were to subtract the first from the second, minus B minus C is equal to minus 150, what's going to happen is the B's and C's are going to cancel, leaving just A equals 30 degrees. We like that. That's really nice. Well, this second equation here has a B and an A, so I can plug A in for that equation really easily. So 2B minus 10 plus 30 equals 180, or 2B equals 160. So B itself must be 80 degrees. And then I can take my A and B and plug in for C in A is 30 plus B is 80 plus C, which I don't know, have to add to 180. That's 110. So C must equal 70 degrees. So I found A, B, and C. There's A, B, and C. And my results are already interpreted because they're already listed with the angle symbols. All right, let's take a look at this one. 2 cement blocks and 3 bricks weigh 102 pounds, as do 1 cement block and 10 bricks. What does 1 brick weigh? All right, guys, first step is to define your variables. And after we have defined our variables, we can write our equations. 2 cement blocks, that's 2x, plus 3 bricks, that's 3y, have to add to 102 pounds. As do 1 cement block, that's x, plus 10 bricks, 10y, also equals 102 pounds. Well, what I'm going to do is I'm going to multiply my second equation by negative 2. So I'm just going to cross him out lightly to make him negative 2x minus 20y equals negative 204, and then add straight down. So my x's would cancel, my y's become negative 17y is equal to negative 102. Divide both sides by negative 17. I get that y is equal to 6. So now I'm going to take that and plug it back in. I know that x plus 10 times y, or 10 times 6, is equal to 102. So that's x plus 60 equals 102. So x is equal to 42. So my blocks weigh 42 pounds, and my bricks weigh 6 pounds. So I have interpreted my results in terms of the problem. All right, guys, I want y'all to try 3B. The answer for this is actually at the end of the notes, so try it and check your work. Now let's take a look at example 4. So example 4 is really a distance, rate, and time problem. We've just got some extra stuff going on here. They say Maddie flew a weather service plane at 1,800 kilometers east with a tailwind and then back to the west against the same wind. The eastbound flight took 2 hours and the westbound flight took 3 hours and 20 minutes. Find the speed of the wind and the airspeed of the plane. So airspeed is the speed at which the aircraft moves through the air, and ground speed is the speed at which the aircraft is moving relative to the ground. It's really your airspeed plus your wind speed. So in this, I'm going to use a DRT table or RTD table. So I have rate times time is equal to distance, and we've got 2 trips. We've got our trip east, and we've got our trip west. And they tell me that time-wise, it's taking me 2 hours to go east and 3 hours and 20 minutes to go west. Well, I can't mix my units, so that's really 3 1/3 hour. Well, I'm going to convert that fraction, that mixed number into a single fraction. 3 times 3 is 9, plus 1 gets me 10/3 hours here. So time is in hours. My rate is in kilometers an hour, and my distance is in kilometers. Okay. Now, our plane is traveling with the same rate in both directions. But going east, it goes with the wind, and going west, it's going against the wind. So really, its airspeed is increased going east and decreased going west. So the distance here is 2 times r plus w, whereas here my distance is 10/3 times r minus w. And the nice thing about this is they're both going the same path, so they're both going 1,800. Both of these are equal to 1,800. So really, when I'm looking for my system, 2 times r plus w is equal to 1,800, and 10/3 times r minus w is also equal to 1,800. Now, I'm going to do something to make both of these a lot easier to work with. I'm going to divide this equation by 2 to make that r plus w is equal to 900. And this equation, I'm going to multiply both sides by 3/10 to clear the fraction, because I don't like fractions. And I get r minus w then. When I multiply by 3 and divide by 10, this becomes 540. Now, that's a really easy system to work with. I just add straight down. I get 2r equals 1440, or that rate there is 720. And I know that that r plus w, so 720 plus w must equal 900, so w must equal 180. So interpreting these results, my airspeed is 720 kilometers an hour, and the wind speed is 180 kilometers an hour. Let's look at the next problem. All right, I want you guys to try this one. Now we're going to go into this one. This is a mixture problem. I love mixture problems. These are really cool. Mixture problems also like tables. Here they say Lynn Pike, a pharmacist, needs 70 liters of a 50% alcohol solution. She has available a 30% alcohol solution and an 80% alcohol solution. How many liters of each solution should she mix to obtain 70 liters of a 50% alcohol solution? All right, so I think the best way to do this is to make a table, and the way to set up a table in a mixture problem is to always remember that your total liters, or volume, whatever it is, times the percent of whatever you're dealing with, in this case it's percent alcohol, is always equal to the liters of alcohol in whatever solution you have. And then along the side here, we have our 30% solution, we have an 80% solution, and we want to eventually produce a 50% solution. I know we're not used to saying 3, but I think it's going to help you guys to see it with 3. All right, let's fill in this table with what we know. We know the percents, right? We know that we need to produce a 30% solution, that's 0.3, an 80% solution, 0.8, and eventually we have to get down to a 50% solution, 0.5. I don't know how many liters of 30 and 80% I have. I'm going to call them X and Y. But I know in the end, I want to produce 70 liters. So that means in the end, I need my X plus Y when I add them together to get me to 70. That's the goal. Now the actual liters of alcohol in these solutions would be 0.3X and 0.8Y. And in this case, to get my 70 liters at 50%, that'd be 0.5 times 70, or in the end, we need 35 actual liters of alcohol in our end solution. All right, guys, this video is about to run out. I need you all to stop and go to part 2 of this video. Thank you.